So now let's look at another machine learning model. It's classification. Classification is a supervised learning problem, and it captures the data into two or more classes. As you can see here, the data is captured into two classes, red and blue. Before we move ahead, I have one question for you. Is it spam or ham? More on this later. So now let's look at the machine learning algorithms. The decision tree algorithm is the one which we discussed earlier. If you remember the playing golf example, you will remember that playing golf was dependent upon the outlook, the humidity, and the windy conditions. This is called the decision tree. Now let's look at another algorithm called random forest algorithm. In random forest algorithm, there are multiple decision trees. As you can see here, there is this one decision tree here, this one, the second decision tree here is this one, the third decision tree here is this one, and the fourth decision tree here is this one. So in random forest, it randomly takes on and tries multiple different permutations and combinations to give you the best model that gives you the best possible output. Now let's look at another example, which is spam filter, a common one. So the input is email, the output is spam or ham. In setup, you will need a large collection of data with examples, each labeled as spam or ham. And note that someone has to hand label all this data. So that's a lot of work. Now, the model will be able to learn and predict new future emails. Now, these features will be dependent to make the decision, which can be a ham mail or a spam mail. The words are free. The text pattern can be decided upon the caps, the types of numbers, and many more things. The non-text feature could also be centered in context as well. So let's say if you receive a random mail from a random IP address, it would classify it as spam. Another famous example is an image classification example. As you can see, this image, with this image, the desired output will be apple. However, with this image, the desired output would be pear. With this image, it would be tomato. With this image, it would be cow. With this image, it would be dog. And with this image, it would be horse. And these are just single images. There would be thousands of images which would be labeled apple. And out of hundreds of thousands of millions of different images, it will be able to determine and classify that particular image as an apple. Let's see another example, a digit recognition example. Here the input will be pixel and grid. As computers can't understand image, it breaks down image into pixels. The output, as we know, will be a digit from 0 to 9. In its setup, we'll need a large collection of examples, and again, this time, someone has to label each digit and hand label all this data, and then it will be able to predict labels of new future digit images. Now there is a famous dataset called MNIST dataset which gives you this labeled data, and if you guys want, let me know and I'll create a separate course focusing on digit recognition so that you can learn that. The features and the attributes that can be used to make the digit decision are the pixels, the shape patterns, the numerical components, the aspect ratio, the numbers of loops, and so on and so forth. Now let's look at another example of ML algorithm in supervised learning. It's called K nearest neighbors or KNN. Now this algorithm can be classified as both classification or regression. K is the number of neighbors used in a measure of distance. Choose odd number to avoid ties. Now what would you choose odd number? So let's see here. Here is the green circle which we want to predict that it depends on it belongs to which class, the triangle class or the square class. Now the distance of its nearest neighbors will be calculated. Now let's assume that the number of neighbors is 3. So the nearest first distance from this point will be of this triangle. The second nearest distance would be this triangle, and the third nearest distance would be this triangle. So based on these three, the two which belongs to triangle class and one which belongs to square class. So it will be classified as a triangle. Now let's say if we assumed number to be 4, which is an even number and not an odd number, then the first nearest neighbor would be the red triangle, the second nearest neighbor would be this red triangle, the third nearest neighbor would be this square, and the fourth nearest neighbor would be this blue square. Now with this, it is difficult to predict as two of them are blue squares and two of them are red triangles. That's why we always choose odd number to avoid ties. And you can choose n number of odd numbers. Now let's look at another algorithm called support vector machines. Support vector machines are a classification in which the separation is done by a hyperplane. As you can see here, there are two axes which are separated by a complete plane. So it gives us better predictive models in some case scenarios. Next, we'll learn on clustering. See you there.